Here is few questions from the paper quantum mechanics. All are party questions. First question is, define the term scattering. In scattering, a beam of particles passes closer to a material called target, and the energies and angular distributions of the particles are studied in the scattering process. What is meant by scattering angle? The angle between the incident and scattered beam is called scattering angle. Third question is, what is meant by cross section? The area available for scattering is called cross section. Define differential scattering cross section. Consider capital N be the number of particles approaching the target in unit time, and small n be the number of particles scattered into a solid angle in unit time. The differential scattering cross section sigma of theta comma pi, which is equal to small n divided by d omega whole divided by capital N. Here d omega is the solid angle, that is equal to surface area divided by r square. Then its value is sin theta d pi d theta. What do you mean by total scattering cross section? The total scattering cross section sigma is the integral of the differential scattering cross section. See here, sigma equal to integral of the differential scattering cross section into d omega, that is equal to sigma of theta comma pi sin theta d theta d pi. Here the sin theta d theta is integrated with respect to the limit 0 and pi, and sigma of theta comma pi d pi is integrated with respect to the limit 0 and 2 pi. For a spherically symmetric potential, which means that if the potential is the function of r only, sigma of theta comma pi is equal to sigma of theta. So sigma total is equal to integral of d pi is 2 pi, and the rest of the quantity is sigma of theta. Theta comma pi is changed as sigma of theta because of the spherically potential nature. The sin theta d theta limit varying from 0 to pi. This is the formula for total scattering cross section. Give the unit of cross section. Unit of cross section is Born. 1 Born is equal to 10 power minus 24 centimeter square or 10 power minus 28 meter square. What is scattering amplitude? The scattering amplitude is the probability amplitude of the outgoing spherical wave concerning the incoming plane wave in a stationary state scattering center. Eighth question is, give the relation between the scattering amplitude and cross section. This is our differential scattering cross section. This is absolute square of the scattering amplitude. So the differential scattering cross section is absolute square of f of theta. Mention the available techniques for evaluating the scattering amplitude. Usually the partial wave analysis and the Born approximation are the techniques used to evaluate the scattering amplitude. What are partial waves? In the scattering process, the incoming wave is a plane wave. A plane wave can be expanded as a linear combination of infinity number of spherical waves. The individual spherical waves are called partial waves. Suppose consider the orbital angular momentum quantum number L equal to 0, that corresponds to S wave. If L is equal to 1, that is explaining the P wave, and so on. Define phase shift. The phase shift measures the amount by which the scattering potential changes the phase of the radial wave function for the given orbital angular momentum quantum number from the corresponding one for the v equal to 0 case. We are studying the phase of the outgoing wave with the presence and absence of the scattering potential. The difference provides the phase shift. What is the value of scattering amplitude in partial wave analysis? This is the value of scattering amplitude in partial wave analysis. The differential scattering cross section is absolute square of this f of theta. What's the value of total scattering cross section in partial wave analysis? total scattering cross section is calculated by the formula 2 pi into sigma theta sin theta d theta integral limit varying from 0 to pi. If you put up sigma theta is absolute square of theta, say 1 by k square 2l plus 1 e power I delta l pl cos theta sin delta l square sin theta d theta. E power I delta l absolute square means e power I delta l into e power minus I delta l, so the value is unity. Then 2 pi by k square 2l plus 1 square sin square delta l, then the rest of the terms are integral limit varying from 0 to pi pl cos theta sin theta d theta. Then the integral value is 2 divided by 2l plus 1. If you substitute this value here, sigma is equal to 2 pi by k square 12 plus 1 square sin square delta 2 divided by 2l plus 1, that is equal to 4 pi k square 12 plus 1 sin square delta l. This is the value of total scattering cross section. What is the value of total cross section for an S wave in partial wave analysis? For an S wave, the value of orbital angular momentum quantum number L is equal to 0. Put L equal to 0 here. 12 plus 1 is 1. Sin square del 0. So sigma t comma 0 equal to 4 pi by k square into sin square del 0. This is the value of total scattering cross section for an S wave. Give the statement of optical theorem. The value of scattering amplitude f of theta is this much. Put theta equal to 0 in this equation. We may get PL of cos 0. The PL of cos 0 equal to 1. So f of 0 equal to 1 by k 2l plus 1 e power I delta l into sin delta l. Now e power I delta l can be expanded as cos delta l plus I sin delta l. Then find out the imaginary part of f of 0. Imaginary part means you have to take the I term alone. Sin delta l into sin delta l, sin square delta l. So imaginary part of f of 0 is equal to 1 by k summation over L equal to 0 to infinity 2l plus 1 sin square delta l. But the total scattering cross section is 4 pi by k square summation over L equal to 0 to infinity 2l plus 1 sin square delta l. So this can be separated into two terms, 4 pi by k into 1 by k summation over L equal to 0 to infinity 2l plus 1 into sin square delta l. So this is our imaginary part of f of 0. So sigma total equal to 4 pi by k into imaginary part of f of 0. The above relation is called optical theorem since it is identical to an equation in optics that describes the relationship between the absorption coefficient and the imaginary part of the complex index of refraction. Next question is, what is Ramseur-Towson effect? Suppose if you consider the S wave is having very low energy. If the incident particle energy is very low, the scattering is described by S wave alone. If you say the value of L is greater than 0, then the value of phase shift is 0, because if the incident particle energy is very low, no need for it to go for higher order. Furthermore, if the value of delta 0 is pi, then the cross section vanishes. For an S wave, sigma total is equal to 4 pi by k square into sin square delta 0. If delta 0 is pi, the cross section vanishes because sin square pi is equal to 0. So the phenomena of no scattering is called the Ramseur-Towson effect. Next question is, what is meant by resonance scattering? Suppose the phase shift is 90 degree, maximum cross section is available for scattering. The phenomena of occurrence of maximum scattering is called resonance scattering. What's the role of Green's function in scattering? Green's function integral equation method solves linear differential equations by expressing the solution in terms of an integral equation where the integral involves an overlap integral between the solution itself and the Green's function. This is the value of Green's function. What is Born approximation? The Born approximation is an iteration method used to evaluate the scattering amplitude. In this process, the wave function psi of r dash is replaced by the incoming plane wave, that is e power ik dot r dash. Say this is the value of theta. Here psi of r dash is replaced by e power ik dot r dash. So this equation is modified as f of theta equal to minus 1 by 4 pi e power I into k minus k dash dot r dash into u of r dash d tau dash. In Born's approximation, what are the factors affecting the scattering cross section? This is the value of f of theta. Then differential scattering cross section is absolute square of theta. Here the value of q is 2 into modulus of k sin theta by 2. The scattering cross section depends on the momentum of the incident particle h cross k and the scattering angle, because q is the function of k and theta. Give the validity condition of Born approximation. Born approximation is valid for weak potentials at high energies. See this integral, this is the condition for validity of Born approximation. In this condition, if the potential value is low, the integral value is low. If the energy of the incoming particle is high, the value 2 mu divided by h cross square k is also low. Therefore, the entire is having value lesser than 1, because if h cross k is more, if the energy is more, h cross k is more. If it is more, the quantity 2 mu divided by h cross square k is less. What are annihilation and creation operators? The operators ak is called annihilation operator. When it operates on a function, it decreases the eigenvalue of the function by 1 unit. Operator ak dagger is called the creation operator. When it operates on a function, it increases the eigenvalue of the function by 1 unit. What are number operators? A dagger a equal to n is called the number operator. It preserves the eigenvalue of the given function. Give the Dirac's equation in covariant form. The Dirac's equation in general form is IH cross dou psi by dou t, which is equal to minus IH cross c alpha dot del psi plus beta mc square into psi. In covariant form, gamma mu dou divided by dou x mu plus mc by h cross into psi equal to 0. Here mu equal to 1, 2, 3, 4. Gamma mu dou mu plus mc by h cross into psi equal to 0, where dou by dou x mu is reduced as dou mu. What are 4 vectors? In Minkowski space, a quantity is called a 4 vector if it has 4 components, each of which can be transformed using the Lorentz transformation equations. X suffix mu is equal to x, y, z, comma ict. Here mu is equal to 1, 2, 3, 4. That is equal to x1, x2, x3, x4. See here, x is x1, y is x2, z is x3, ict is our x4. So these are all called 4 vectors.